Hello, my name is Ashton Jakubiak, and today I am joined by Daniel Meneses and Camilo Ricaurte. We are focused on 3D printed dental retainers, and we have a lot to show you today. For the background of these retainers, retainers have been in use since the 1970s, and since that point, we've made a lot of advancements in the medical field. And this, since we have made such advancements, orthodontics has really exploded, and now we have a lot of companies that deal in orthopedics. Some of the companies that deal in the orthopedics are Hess Orthodontics, Clear Retain, and Sporting Smiles. In 3D printing, though, according to the evaluation of fit for 3D printed retainers compared with thermoform retainers by the American Journal of Orthodontics and Dentofacial Orthopedics, the article also focused in on the variations of size for 3D printed retainers, and what they found was that the 3D printed retainers were considered clinically sufficient. For our objective, our general objective was successfully developing a durable resin retainer that could closely model around the mold of the teeth that our group had acquired. Also, it was done specifically to see if we could get the results of a commercially available retainer using the 3D printer from the lab to 3D print some clear plastic retainers from resin, yes.
Okay, now I'm gonna speak to you for the design process. For this part, we start by obtaining the 3D model we were looking for and then obtain the retainers. During the design, we found out that the easiest way to develop a 3D scan of a denture is through machines very common in medical schools or medical offices. Unfortunately, we couldn't get access to any, so we used the 3D laboratory scanners without success to its poor accuracy uh, because it was too difficult to scan inside the mouth without the necessary instruments, and also the difficult of scan little objects like the teeth. Given this, we use an online surface model of a denture, which we scale and join all its surfaces with SolidWorks to turn into a solid object capable of printing in the lab. Once we had this model, we used the Mesh Mixer software to select only the surfaces of the teeth to extract and work with it, extruding it and giving it a thickness of approximately 2 millimeters. For the manufacturing process of the dental mold, this process was different from the retainer because in the dental mold we use the flash for printer with PLA plastic. This is a simpler process with a printer a little less accurate, but still provide us a good surface uh, and finishes of the to the impression. For the retainer, we use a 3D printer based on ultraviolet light. And the reason we did this is that it will produce the most accurate model, given the design and nature of the retainers as very small and thin objects. We use a thickness of 2 millimeters by the recommendation of the technicians due to the complexity of the object. Additionally, to correctly fabricate the retainer, these ones were printed through small columns of filaments so that the material doesn't overflow the retainer. So we can get the piece with the dimensions and shape indicated. on the software design.
As you can see, here are the results from the 3D printing. The left image is the teeth model that can be easily made from PLA or ABS material. In this case, we used PLA. The image in the middle is the retainer printed just how it came out from the printer with all the filaments. And the right image is the retainer after removing all the rest of the resin. Here we have pictures of the top and bottom view of the retainer, where we can notice that this came out well with a good shape, but we can also notice that it is thicker than usual retainers, which can be a little uncomfortable for the users. With these results, we could say that with a few modifications, this method could actually be used for making retainers. The main modifications would be to use a better 3D printer, looking for more precision and one that can make objects with a smaller thickness, because as you saw, the retainer was very thick, which is unconventional for this kind of product. Another modification would be a better selection of the material for the final retainer, looking for one that is more flexible. And finally, the last modification would be a better polishing process to make the retainers the most comfortable possible, leaving out any harm possibility for the users. Well, even though this is a decent method, it is not better than the conventional one used by dental clinics. This one being cheaper and more effective, giving a better experience to the patients. Well, we tried to use this method, but we couldn't due to lack of resources. Well, these are the reference that we used. And well, that was all. Thank you all for your attention.